Thank you for coming to the talk. When will AI take my job as a tester? As you've probably noticed, AI is a bit of a hype topic these days. And actually, this is the third talk at this very conference that is talking about AI. And as some others have already put up the questions, some other speakers already put up the question, whether you as a tester will use your job to AI. And I personally think that AI will become much more powerful over time and eventually will take all jobs. So I think AI has the potential that maybe in 50 years or something, it can take the jobs of developers, of managers, essentially of everybody. It can eventually do all the work. So the question is, in my opinion, not whether it will take your job, but when. Should you be worried? Will it be in 5 years, in 2 years, in 6 months? Or will it be in 10 years, or 20 years, or in 50 years? And this is a very relevant question, I think. And so I'm trying to talk about that today. So, but first I want to know a bit about you. So, who of you is a professional tester? Okay, that's almost anybody. Those who are not, who has ever tested, at least once in his life? Okay, more hands. And who, if not ever tested, who has ever spotted a bug? Okay, and there are still a couple of hands down. Who uses Windows? Okay, so this should settle the question. So now we have established that we are somewhat professional in terms of testing software, and because most of you are professional testers, or at least have tested once or spotted a bug, I have a very easy question for you. So this is software, and there's a bug, or there's not a bug. That's actually the question. So I want you to answer whether this value that you can see here is correct or not. Who wants to give the answer? I mean, we're all professional testers here, so it should be easy, right? What do you think? Is that correct or not? Well, nobody wants to answer, because how could you know? You don't know what software that is. You don't know what it's supposed to do. You don't know what data went in or how it's configured. So how can you possibly answer whether this value is correct or not? Right? And frankly, AI is in exactly the same situation. So if AI doesn't know your software, doesn't know what it's supposed to do, doesn't know what data went in or how it's configured, then AI also can't answer this question. And this actually is an instance of the Oracle problem. And the Oracle problem, I would argue, it has a very fancy name for a seemingly easy problem. But I would argue that the Oracle problem is the hardest problem of all. Because if you could create an AI that for any given software could answer whether the output is correct or not, you could ask any questions. Right? You could, for instance, create a software, 3 lines of code, that always returns no. And you could ask it, does God exist? Then your software would return no, and then your Oracle would need to decide whether this is correct or not. So your Oracle would need to decide whether God exists or not. And you could put in any question. You could put in, would the software halt? So is solving the halting problem. Or whatever, am I going to die in 10 years? Something like that. So you could ask it any question, and in order to correctly identify whether the result is correct or not, your software would have to be not only all-knowing, but all-correct, right? And this is the reason why that problem is called the Oracle problem. So you as a tester, when somebody asks you what I do for the living, now you can say, I'm working on the hardest problem of humanity. Because you do. You solve the Oracle problem on a daily basis, right? So, chapeau. But of course, not all problems are that hard. right? This is a simple instance of the oracle problem. You can decide whether this value is correct or not without knowing whether God exists or not. So, but it's the same instance of problem. It's just the same range, the same difficulty overall, but it's a simpler instance of the same problem. So can we bring AI to solve that simpler instance of the same type of problem? Well, in order to be able to decide whether that value is correct, you have principally two options. Either you can decide by yourself, which means that you make the decision what the program should do, what the correct output should do, or you understand someone else's decision. So, if you think about software in general, usually that software solves a problem, addresses a pain, or an unknown desire, or a fuzzy need. But it's always some sort of problem or challenge that comes with an inherent complexity. And in order to be able to address that problem, you need to understand the inherent complexity. And from that, you can generate domain knowledge. So you are not generate, you have to get domain knowledge. For instance, if you create a software that calculates your taxes, you have to understand tax rules. If you want to create a software that, I don't know, manages your customers, you have to understand how that management should work. So you have to understand the complexity, the inherent complexity of the problem you want to address. And only then can you decide how you want to solve that. Only then you can say, okay, I want to create a CRM system, a customer relationship management system that has these and these features and not other features, or vice versa. So if you think about the person who decides how the problem is going to be addressed, then you're talking Steve Jobs. Okay? Then you decide, or Mark Zuckerberg. Then you decide whether you want to create MySpace or whether you want to create Facebook, because both address the same problem. Then you decide whether you want to create Snapchat or Instagram, because they both address the same problem, just differently. You have to decide whether you want to create WhatsApp or Skype, because they essentially both address the same problem, communication, right? Photo sharing, mobile phone, and connection. So, of course, in most situations, it's not so clear-cut. So in most situations, these are the two extremes, right? The one hand side is the CEO, is a Mark Zuckerberg or Steve Jobs, who decides how the future of Facebook, for instance, should look like. And on the other hand, you have someone who gets told exactly to the point how something should be implemented and executes. But mostly, you have something in between, right? So somebody, the CEO or the product owner or whatever, product manager, or whatever that is in your specific situation, has a vision of what he wants, and then he tells you, or anybody tells somebody else that vision, and then you fill in the gaps. Then you apply common sense, you apply maybe your own creativity to fill in the smaller details that are missing, right? But these essentially are the two extremes that you have. You can either decide on yourself, or you can understand someone else's decision. So, and as you go down there, the complexity of the problem wanders. So the complexity is, first of all, within the problem. Then you have to understand the domain and the complexity that lies within the domain. Then you have to create a plan, how you want to address that problem. And that plan needs inherently to cope with the complexity. So the complexity of the problem gets handed down, gets handed next to the next stage. And so whoever is making that plan, if it's the CEO who's making the vision, the Mark Zuckerberg, the Steve Jobs, whoever, he has to communicate that solution. He has to communicate the plan, how he wants the problem to be solved. And creates, within someone else, creates the solution knowledge. How am I going to implement that? And that knowledge, this is probably, at some point, it's a developer. So, I mean, the CEO tells the product manager who tells whatever. So, but at some point, you have a developer. And the developer formalizes his understanding of the solution as code. He programs the solution, he develops it. And then you have code. And the code also encompasses the complexity of the problem. So, this is how software developers see the world. Because they take the complexity and hide it behind a simple-to-use, intuitive, easy-to-use software interface. I mean, that's the ideal world, right? But this is what you want. This is a goal. You have a very complex problem like tax calculation, and the aim is that the user doesn't need to do the tax calculation, right? The problem is hidden from the user. The user just inputs his, I don't know, income and other numbers, and the software solves the complexity. It hides the complexity from the user and calculates the tax, for instance. A very easy, very simple example is authentication. If you think about authentication, proving that you are you, it's a very hard problem. Think about the police. They take how's it called? Fingertip, sorry? Yes, so they take thumb impressions, they take iris scans, they take blood cells to prove, and then they create a passport or an identification certificate which you can show to prove that you are who you claim to be, right? It's a very hard, very complex problem. And that problem is simplified by that screen. Just giving a correct username and password combination, the software assumes that you are who you claim to be. So this very complex problem, this very complex real-world problem, is solved and hidden within software. And the user has a very easy-to-use interface. He just inputs username, password. He is who he claims to be. That's at least. And as testers, usually, you do address the need or test in the shoes of the user. So, that's what I wanted to stress here. The purpose of software, most of the time, not all of the time, but most of the time, the purpose of software is to make your life easier. And this is an example that I just gave. Sorry. Right. And if you think about what is happening technology-wise behind that screen, then you have the HTML, which is layouted in some way with CSS. You have to persist all the data. You have a data model that declares the relation of the data to each other. You have some glue code in between. You have a software architecture. You have the cryptographic algorithm to correctly, you don't want to store, for instance, the password in clear text. So you have cryptography, also logging, scalability, load balancing, and a lot of that complexity just to solve a very, well, for the user, apparently very simple problem, right? And enter username, password, and I am who I claim to be. And all of that is hidden from the user by this screen. So the user, on the user side, it's very easy. He has to recognize components. For instance, he has to understand that this is a text field where he can enter text. Then he has to do that, enter text. Then he has to click, for instance, login or some sort of confirmation. And he has to provide simple data, username, password. So this is how software developers understand the world. And you, as testers, are now in the shoes of the user. So you, as testers, have these tasks. And this is also the reason, as being testers, who has ever experienced developers looking down on them? Like, testing is easy, can't be too hard, why don't you do it faster, find more bugs, whatever. So this is because of that. This is how developers see the world. For them, They have all the complexity here, and you have it simple. Come on, testing is easy. Simple, intuitive, easy to use interface. Testing is easy, right? This is what developers think. This is how they perceive the world, and this is also why they say, okay, since testing is so easy, let's use AI for that. Let's apply AI to solve the problem of testing. And, sorry? What they don't realize is that when you do testing, you have a circle here. So the developer formalizes the complexity into code, and you, as testers, do the back thing. So you have to understand the solution, and in order to be able to test and check whether what was implemented is correct or not, you have to go back that and understand the solution and make the check whether what is actually implemented is what should have been implemented. So in order to be able to find defects, you need to understand the solution. Okay, so when I ask what do you do as a tester, there are many different things that come up. So this, for instance, is from the Ministry of Testing, and there are many different tasks that you need to do. But the most important task in my perception is understanding users. You are in the shoes of the user, and you test the software from user's perspective. So in order to do that, you not only need to understand the solution, ideally, as a very good tester, you also understand the plan, and you also understand the domain knowledge, and you also understand the underlying problem, and all of that complexity that resides within. So if you want to test a tax software, ideally, you understand the rules of taxing. You understand what domain knowledge there is, you understand how tax is calculated, you understand how your software addresses those issues, addresses those problems, how the overall vision looks like, what your CEO or project owner or whatever wanted your software to be, and then you can test what the developers implemented, and then you can find all the defects. But that means, in order to be able to do that, you need to understand the complexity of all of those levels, right? And this is what developers don't see when they say testing is easy. And this is, now we want to take AI and do that. Now we want to take AI and say, okay, test my software, find the defects. Well, obviously, this, as of now, is not possible, at least not that way. And here's a good example. So this is an account creation screen, and it says password is being used by Rovaldo37189. Please choose another password. Maybe somebody can spot a problem here. Sorry?
Use a username directly so that anyone can use it.
Right. So if you brute force attack that, you can get username and password combinations for existing users. And it's not like, on first sight, if you just don't understand the problem domain, you wouldn't understand the problem. You wouldn't see the risk that comes associated with that, right? So you need to understand what problem that software is solving in order to be able to understand that this is a very major security issue. And right now, AI can't do that. AI doesn't understand what purpose your software solves, what problem it addresses, so AI can't tell you, be careful, we have a problem here. So, as I said, we can't do that, but maybe we can do something simpler, right? Maybe we don't need to go all the way up to the original problem. Maybe we can just verify that the solution is a correct formalization, that the code is a correct formalization of the solution. Well, for AI, in order to be able to do that, it would still need to understand the solution, right? It would still need to, talk to stakeholders, to interpret or understand the specification, to understand the documentation, to understand whatever backlog feature, backlog items, whatever it is that you use in order to manage yourself and understand what the solution actually should look like. AI would have to be able to understand that in order to check this circle and whether the solution is a correct formalization, whether the code is a correct formalization of the device solution. But if AI masters that complexity, why not have it create the software in the first place? What do we need developers for? If we can create AI that is so powerful that it understands the solution that I want, then I don't need the developers. I can just use AI to generate that solution, right? So that graph then looks like this. As soon as AI has the solution knowledge, it just formalizes that solution into code, because code is the ultimate specification, right? Code is the unambiguous specification of a software. It tells the computer what the software is, so the computer can execute that software. And if AI can understand the solution, it can come up with a formalization of that solution, which is the code. And it can even do so error-free in terms of its understanding of the solution. So a developer might understand the solution, and when formalizing it, might put in errors, right? He might put in bugs. He understood what was wanted, but for some reason, null pointer exception and whatnot. So he puts in errors. He understands what is wanted, but still does not correctly formalize it. The AI would do so correctly, like a compiler does, right? Compiler takes your source code and compiles it into machine code, and it does so almost error-free, right? I mean, in terms of the source code. If the source code is not correct, then you end up with bugs in the machine code. That's true. But the transformation from source code to machine code nowadays should be error-free. And this is what you could have with AI if it understood the solution. You could get a correct implementation in terms of that solution that was understood by AI. And then it would be very cool, because we still would need testers. Then the testers would test that software and would revise the plan, right? They would tell the AI, oh, you thought that that button should be red, but actually, when I go back and talk to the CEO or the project manager or whoever, then he tells me that button should be green. So please change the color of the button to green. So you would still need testers, even if you could generate the code without the need of developers, right? So, coming back to our original example, where we say that software is very complex. You have the GUI, the layout, the data persistence, data model, and all of that stuff. And here, everything is easy, right? Because it's just component recognition and executing some actions. Well, if you look at that and think about what I just told you about how the future might look like, how far are we in that regard? Well, for instance, thinking about the GUI. There's already software, existing software, that takes a sketch on paper and turns it into layout, into a GUI. So you just draw what you want, and the GUI is generated from that. I mean, it's early, it's in infancy, so it's not, I wouldn't use that in production, but it shows that it's possible. So we can remove the GUI and layouting. That's very easy. Okay, what else? Data persistence. Well, as you probably know, if you have, there are existing prototypes. If you have an existing GUI, then that GUI tells you what data goes into your application. So you can extract the data model from the GUI. So, okay, oh sorry. So you can get rid of the data persistence and the data model. And the data persistence actually is usually a database, so that's a solved problem, right? Same with cryptographic algorithms. You wouldn't want to implement it yourself, you just take a library for that. So the developer doesn't need to implement it himself. And actually, this is true for most of the things that you see here. Usually you have a make or buy decision, and as you can see here, most of the time it's a bad decision to do it yourself. Most of the time you want to buy stuff. Because if you buy, for instance, a database, you can assume that the code quality is better, that it has more tests, that it's better documentation, that it's cheaper to buy it, even if it's Oracle, than to implement it yourself. The only reason, actually, to implement software yourself is if it's special in any way, right? If you need, if you want to solve a special need, want to address a special need, then you implement software or parts of your software, for instance, data persistence, then you implement it yourself. But if you can use an existing solution, most of the time it's a good idea to use that existing solution. So again, if we go back to that, we can get rid of, logging, scalability, load balancing, cryptography. That are all solved problems, right? You don't want to solve that yourself. So eventually, if you're not in a very special situation, if you're not an IoT programmer or a cryptography programmer or a database programmer or something like that, like if you're working for Oracle creating a database, then the situation is different. But for most, like for 80% of the developers, what they should do, what they should focus on is glue code. Take existing things and stuck them together. You don't want to implement HTML yourself or Swift yourself or a mobile, whatever, a GUI library yourself. You want to take existing libraries for that. You want to take existing frameworks for that. So what you have to do is create glue code and stick those stuff together. So if you think about AI, that situation now becomes much easier, right? Because now you don't need to generate a database. You can just take a database that exists, and you just need to generate a data model for that, which is much easier. And there are even, these are not AI systems that generate glue code, but these are systems that focus on that glue code, right? And now, if you think about test-driven development or BDD testing, and you have an account, you have a test like this. Given a customer account exists and the customer account is activated, when the customer enters username and password, then the customer should be logged in. So what do you think is easier? Generating that test from existing specification, documentation, or talking to stakeholders, or once that test is created, generate code that makes that test pass? Well, in my opinion, it's easier to generate code that makes a test pass. So what you end up with is the situation that you want to generate software and test it manually to verify that it does what it's supposed to do, but generate it. So it turns out that although many people say testers should be worried, I think developers should be worried, which is a good thing for you, right? But don't be too sorry with them, because nowadays software developer bumps healthcare for the best job title. So it's these guys are looked for. They get high salaries in most situations, especially in Silicon Valley. So we actually need that in order to come up with enough developers. Software is eating the world, as you all know. So we need developers, and anything that helps releasing the pressure on the amount of developers that we need is highly welcome, in my opinion. So we need these sort of systems. And you still need developers for special case development. Like you want developers for IoT, you want developers for databases, you want developers for specific needs. But for your typical mobile application, you just want to generate the glue code that sticks it all together, right? Okay, coming back to that. As I said, I think this is the plan for the future. This is how long-term you have a tester that tests an AI-generated solution and feeds back, gives the feedback to to the AI to improve on that solution, iteratively. Okay, so this means we can't bring AI into testing at all. So we can't, testing is purely manual and we can't do anything with AI in there. Well, that's not what I did say, because it's still the way that executing the software is easy, right? What AI can't do is understand or identify defects, but executing software is easy. So what we can do today with AI is, because we only need to we only need to address those problems, is we can use AI to execute the software. So because it is so easy, like developers think, to execute the software, we can just use intelligent monkey testing, execute the software and find either defects, like a null pointer exception or any crashes, or, this is based on the infinite monkey theorem, where the idea is that if you have a monkey that uses a typewriter for a long enough time, eventually it will write William Shakespeare, and you just replace the typewriter with a computer. So this is monkey testing, and you can use AI to improve that. So you want an intelligent monkey with a bigger brain like that. And this has already been done. So these are existing solutions. This is not a product that you can buy. It's been deployed within Facebook. And they said for quite a year, for some year or something, that they wanted to make this open source. But as far as I know, it's not open source yet. But it's existing software that's applied on a large scale range within Facebook. So they use monkey testing, intelligent monkey testing, to find defects within their applications. But sorry, that was too fast. If you think about regression testing, or test automation, if you think about test automation, which is a huge topic, what is test automation about? Test automation is about preventing unintended side effects, to make sure that the software works as before. So if you have a large software with many screens and you just change one, you want to make sure that all those others don't change, right? This is the goal of test automation. And with that in mind, I would argue that regression testing is not testing, because all those bugs that are in there, you won't find with test automation. Test automation just makes sure that no new bugs are introduced, but the bugs that are already in the software can't be found with test automation. And this is good. This also means that test automation is essentially version control, right? Because you don't test the software in the means that you find bugs that are there. You just guard it against unintended side effects. And this is good because, as we said earlier, AI can't identify defects. AI can't understand what your software should do. But if regression testing isn't testing, well, then maybe we can use AI. If version control works like this, you have an old version, you have a new version, and you show the differences. And then someone says, yeah, this is what I wanted, or no, I introduced, this is crap, discard it, right? This is essentially version control. And we can do the same thing with software on the UI level. We can say, okay, this is what it looked before, this is what it looks now, is this wanted? Then we can just approve it. And because there are different approaches to this, the simplest approach is, of course, pixel-based. So there are many tools, some of which were mentioned earlier, for instance, apply tools. But there are many, like, I think there are even more, like 30 tools that do this, and most of them are even open source. But of course, it's a bit fragile. And then there's text test, which is for Python, but works the same. Or approval tests, if you have heard of that, or Jest. This is also from Facebook. This is for React programming. And actually, this is a commercial part of the talk, because we at Retest created a tool that also does it. It's called Recheck. It's currently implemented for web apps in the version 1.0. So if you have some free time on your hands, I would recommend you check it out. But this is essentially, all those tools do the same. They just check for unintended side effects. And if you do that, then you can use AI within monkey testing to improve the monkey. You can use artificial neural networks, you can use genetic algorithms, you can even combine those two and make the monkey even more intelligent. And then you can use a user to train to train the AI. For instance, you can, with an artificial neural network, you can train how typical users use your software, or use software in general. Like the neural network can learn design principles. For instance, buttons that are closer to each other are more likely to be clicked after one another. Or genetic algorithms to train it with your specific use cases. Like you want to give it username, password, then you use genetic algorithms in order to not use too many learning examples. So the scenario with that looks like that. You have a version 1.0 that you manually test. You need to manually test. There's no way around that. But while doing so, you can already train the AI how your software works. Then the AI can automate those tests. You don't need the automation. Like you wouldn't need developers in the future. You maybe in 2 years don't need automation engineers anymore because you have AI automate the tests for you. Then you have a new version of the software, 1.1, and with that you get a diff. So some things change. Maybe you added a field, maybe different data is shown, maybe a button was removed, stuff like that. And so you get a diff. And then, because of the Oracle problem, you still need a user to look at those changes. You still need a user to check whether these were intended changes, whether this is how we wanted to change the software, or whether these were unintended side effects. So, and now I have a short couple of slides about how to bring AI into coding, but I'm afraid I used up my time, so I'm going to skip that. I just wanted to say that you don't do it at once, you do it feature-wise, like you don't have self-driving cars all at once, you have individual assistants, and you add assistants until everything can be done by an assistant, and then you combine them into a self-driving car. So this is the same how you would do it with AI in coding. So you do the simple tasks first, for instance, generate test cases, which is the simplest task that you can do, to generate code, to automate test cases. And then the next step would be to automatically find bugs, and there are already systems for that. So again, Facebook has with, what's it called? It's, sorry, I don't see it right now. Sapfix, that's the name. So on top of Sapiens, which generates tests, you can now generate bug fixes for defects. And there's already existing software that does that, widely deployed. So this is within Facebook, thousands of developers are using that. So, and what I just showed you was a glimpse into the future. And the systems that I showed, like generating existing GUIs from a sketch or bug fixes from tests, using AI for that, this is just the start. So if you think about how the internet looked like 20 years ago, it looked like that, right? And nobody would assume that we would get Airbnb and Facebook and whatnot, all of these giant companies that we have today, and all of these like LinkedIn and Twitter, all of that stuff that is changing life in such a fundamental way. And the same is true for AI. In my opinion, this is the state of AI in regard to test automation and code generation. So, I'm done with the talk. Thank you for attending.
Do you have questions?
And I hope there are questions. And I have, as other speakers before, I have some vouchers for the best questions, some t-shirts.
Thank you for your presentation. My question is about, of course, our future. Do you think we can get the moment that the future comes and now AI is almost in a perfect suitable for testing, or it can be only evolutional and long process. For example, now it's suggest you best test cases. Now it's clusterize your test your data from your user to test cases. Now it's help you to avoid flakeable tests and so on, and then it comes to some good software solution or something like that. Or it can be like, I don't know, like very sharp thing that says, yeah, this is a AI standard and something invent very full software, and we like, I don't know, like Selenium, it's a standard now for web testing, and now we can rely on, I don't know, something like Applitools for image comparison. Actually, I just wonder also why there are so many of tools for comparing images. Sorry for a long question. Thanks.
So the question was, as I understood, or the main part of the question was, will it come with a big bang or will it come in small steps? Right. So, and I have two answers for that. One is that, as I said as I skipped the slides, that would have said that for the self-driving car, I think it won't come with a big bang. So you have individual assistants that take small parts of the task and automate them, and then you put it all together, and then at some point you have a self-driving car. But that might seem like a big bang. So we have been developing self-driving cars since 20 years. If you think of all the individual assistants, like brake assist, lane assist, park assist, all of these assistants, they have been developed for the last 20 years. And now people say, oh, big bang, we got self-driving cars. So it's a bit of both, in a way. And the other answer is, there's a common quote that says, the future is already here, it's just unevenly distributed. So, I mean, there are still companies that use COBOL that have a code base in COBOL, right? So there will always be companies that are behind, and there will always be companies that are at the frontier, at the bleeding edge of technology. And I mean, developing on which company you work at, you will either be one of the first ones to use AI systems or be one of the last ones. But there will always be a need depending on where you are, I think.
Hi. So 20 years ago, we had a slow network,
Yes.
old browser, mostly text-based,
Yes.
but it worked. What is your opinion regarding artificial intelligence today for software testing? Is it already in a stage that it works?
That's a good question, thanks. So we have a company, a startup that also creates a product that employs artificial intelligence to generate test cases. And I personally, when I did my PhD, I assumed in the ivory tower of academia, I assumed that test generation is a solved problem, and then you can do interesting stuff on top of that. So I think that there are, like 20 years ago, many people didn't know the World Wide Web existed, and only a few people used it. And then at some point, as the connection became faster and as computers were more widespread, then many people were discovering the World Wide Web, and you probably know the AOL and all of those companies that existed. So before that boom, the internet already existed, and it was a niche product or a niche technology. And I think the same situation is here with AI. So AI exists, and even existed for 50 years, in very niche technology pockets where it's been developed and where it's been improved on. And I think that maybe at some point, I mean, as I said, we're a startup in that regard, so I think it will come. At some point, it will be much more widespread. As soon as I mean, you showed in your talk that current AI has many drawbacks and it doesn't work properly. So you have examples where it works good and examples where it doesn't work good. And as you address those issues one by one, iteratively improve on it, then at some point you have a very well working system, and then adoption should be quick, I think. So you can show that in some instances it works well.
Thank you very much for this presentation. As I have one question, as you have told, your opinion is that artificial intelligence could be widely used in automated regression tests. But what do you think about exploratory testing? Can you predict that today you can see some seeds or some roots of modeling of exploratory testing? What do you think if sometimes there will be time when the robot could be spontaneous as exploratory tester? Could you see the roots in this day? Thank you very much.
Thanks for the question. So the question was whether AI could be used for exploratory testing. And as I think what I tried to convey with the slides is that testing consists of two parts. That is executing your software, and checking for defects, right? And I think in one regard, it's a more or less solved problem. So you can use AI to execute large parts of your software and execute large parts of the functionality. But what is an unsolved problem, and what I think it will remain unsolved for as long as anybody has a job, is to use AI to identify a defect, so to check the correctness of the software. This is what I think.
Well, the risk is very small, on your opinion.
I think the risk for AI to do exploratory testing to identify defects is very small. Yeah.
Thank you.
Are there any other questions?
Hello, thank you for the talk. So my question is about actually training. From my understanding, and I'm not expert, so I don't really have much knowledge on the topic, one of the hardest part about AI in modern day is have the correct data set and generally making the right choices while training it. So as a tester, you don't really want to spend all the time checking all the results and confirming that your data set was right when testing. So my question is basically how training works. Thanks.
So thanks for the question. The question is how training works with AI. And for that, I would need to go back to that slide. Sorry. No, sorry. That slide. So the interesting thing is that there are different approaches to artificial intelligence. And one, for instance, artificial neural networks, they need a lot of data to train them. And the other one, genetic algorithms, they need just a couple, just 2 or 12 or 50 examples to work properly, depending on the problem domain and other specifics of the software. But you can, so what we did is we trained the artificial neural network without, how should I put that? In a general way. So the artificial neural network can be used for different softwares. It understands how software works in general. And then you just need a couple of examples to put into the genetic algorithm. So in that regard, I think the challenge for vendors, tool vendors, AI tool vendors, is to come up with systems that don't require testers to come up with a lot of examples, to label them, and to train the AI, you know, to minimize the challenge of training the AI. And I think there are possibilities to do that.
One more thing. Talking about genetics algorithms, again, I'm not an expert, I don't really know much, but I've seen a lot of examples when genetic algorithms would came up with things that humans didn't anticipate. Yeah. Like they would cheat the systems, they would do stuff people would never do, just to get some goal, because the genetic algorithm would award them for doing stuff in a certain manner. Yeah. So basically my question comes to the, like, wouldn't there be a problem of like needing to double check on what AI is doing? Because, you know, if if it, for instance, genetic algorithm comes up with something that basically cheats the system or anything like that, it wouldn't make much use of this AI stuff.
That's actually a very good question. And that is another reason to combine different approaches. So you could, for instance, use an artificial neural network to understand how software works in general. And then when you generate test cases, you could use the artificial network to rate those test cases and tell whether these are test cases, something that a human would do, or whether this something is something that a human wouldn't do. Right? So you can use the neural networks to rate those test cases, but this is anyway, this is a problem. So this was also an early problem for us. So when we just generated test cases without training, we would come up with very weird examples that would crash the system, but that the developers would tell us, we don't care because nobody would ever do that. So this is actually a real problem, and I think that it will continue to be a problem. So you need to be aware of that and watch out for that. Thanks for the question.
Is there any other question?
Okay, so thank you for attending the task. Remember, the talk. Remember when you go home that you are working on the hardest problem of humanity, which is the Oracle problem. And now I have two T-shirts to give away. So because I have a bad memory, could please everybody who asked the question raise their hands again? So I see. All right. So I would give the. I think your question was very good, and yours was very good. Thank you. Okay. So thank you for attending the talk and fun at the conference.